Another important concept is the central limit theorem, which is basically says that in some limit of largeness, namely when you take a random variable and form the mean or the sum of lots of random numbers, which we're implicitly doing when we're doing the histogram, because we're forming the sum over every event of the probability that event turns up heads. So we can think of the counts as a sum over many random variables, and then the central limit theorem says those random variables, when you sum over enough of them, are always distributed with this Gaussian or normal distribution. Then we've shown that both empirically by generating these count distributions and showing that they actually agree with the Gaussian distribution, which was the red curves we plotted on lots of our results. This is the same thing being done by Wikipedia, and here you start off with a dice which has 6 possible sides. Then if you just toss the dice once and write down the probability of seeing the number 1 to this, you just take the number on the dice, then you will have equal probability of being from 1 to 6, and that probability is 1/6. Now we toss it twice. That's this one here. And we add the numbers on the dice, so that's the number between 2 and 12, and you get some plot which is peaked in the middle and falls off either side. Here at the bottom we have n of 3. Now the number goes up to 18, n of 4 and n of 5. And here you can now see actually this rather pretty bell-shaped curve, which I can't do very well with my highlighter, but that's your Gaussian distribution, showing that even for 5 dices, the total score on the faces is well given by a Gaussian distribution. And here it's not easy to see. You'd have to go to the Wikipedia article. You can see that this is the solid curve is the expected Gaussian distribution centered on the mean, and the various other curves of different colors and different dashing of the line. These correspond to the what you get from the dice. The last figure here also comes from Wikipedia, and it basically says exactly what we've done already. That if you take, this is the example we did with, well, actually, this example is exactly what we did. Of, well, not quite exactly, but very similar. We have, we're plotting various sample sizes. We're taking the mean value of that sample sizes, and here we have 250 sample distributions. The mean is 50, and you can see that we have here a pretty good Gaussian distribution about that value of 50. And even for n of 30, it's not quite as good, but it's still pretty Gaussian. In fact, this is the thing done numerically, which is what we demonstrated actually with our Python code. Here is the actual, the equivalent of our red curve, the normal distribution for this example. And there's some measure of quality called chi-squared, which is good if it's less than 1, and these all have good chi-squareds. So this says, again, when you do something many times and you add things up, you will get Gaussian distributions. So that's the end of this lecture, and next time we will go on to a totally different topic, that of e-commerce, where we'll study how to match people to books and music and things like that. Thank you very much.